So want to welcome everybody to the Raleigh Astronomy Club indoor meeting for October of 2020. Thank you all for joining. So today's agenda topics, we're going to have a very interesting conversation with our former club members, Michael and Lehnanne Kidd, about building a remotely operable observatory. We'll take a quick break. We'll get an update from our treasurer around some membership items. We've got some news to share around astronomy days. I don't think our Alcor is going to be here. That's the Astronomical League coordinator. I got a text from him, but I might be able to provide a quick update there, as well as kind of open it up for any other business. So with that, I'm going to introduce our speakers about building a remotely operable observatory. So Michael Kidd, not only a former member, but also a former submarine nuclear reactor operator, a Linux geek, a Nikola Tesla nut, just look at his tattoo, and a polymath. Michael and his spouse, Lehnanne, have been traveling the country in their RV for over 13 years. This mobile life has allowed them to explore dark skies, observatories, museums, rocket launches, and the Northern Lights, all while Michael telecommutes for his day job at Red Hat. Michael got bit by the astronomy bug in January of 2012, and the itch has not let up. I will say I do remember meeting Michael out at Big Woods, and at that time I think it was a Nexstar 8 that was the first scope I saw him with. Yep. So Michael and Lehnanne are going to join us this evening to talk about building a remotely operable observatory under Bortle 1 skies in southern New Mexico. Bortle 1 being incredibly dark. So we'll discuss the considerations and concerns that went into the build, as well as how the observatory is designed with the equipment and safety in mind. So with that, I will kick it over to Michael. And Lehnanne, thank you.
Hi, I'm Michael.
I'm Lehnanne. Whoops, I'm knocking things around already. I'm Lehnanne.
I'm going to just go ahead and get right into the slideshow. We'll bring Lehnanne on for any questions directed at her as they come up, and otherwise
the patient spouse.
the very patient spouse, yes. Otherwise, I'll be your presenter. So we just got the introductions out of the way, so we'll skip this slide. So first off, what are the requirements? First off, of course, is a very understanding significant other, and a good location, a building, a roof that moves, and you need power, you need an internet connection, and you need to be able to fail safe by design, so that the equipment is protected, because you do have a big investment in the equipment. And if you have some on-site help, that is a great benefit as well. Again, special thanks to my lovely and highly tolerant spouse. She was very patient while I was doing all the research for this. I literally spent months after I made the decision to build the observatory, just going through design ideas, every web post I could find, blogs, everything, and just trying to put together the best of the best for my money that I wanted to spend. Along the way, I had a lot of help from fellow geeks, fellow astronomy geeks, Mark, who's watching right now, Don, Dennis, Jason, Eric, and Chris. And ultimately, for the location that I ended up putting it was at Rusty's RV Ranch. The owners of Rusty's and the helpers there, Rusty, Tim, Bob, and Rick, were all great help in making this a reality. So first off, location. You want clear skies, low light pollution. You're building something that's permanent, that you can operate from anywhere. So you want to make sure to pick the very best that you can get, at least that you can find. Dry weather is also great, because the less humidity in the atmosphere, the less reflectivity you have and the better clarity you have. Security is a big part of this too. You don't want your equipment walking off because you're not there with it to protect it and, you know, see if somebody is walking up to it or whatever. Again, I opted to use Rusty's RV Ranch. It's in Rodeo, New Mexico, which is actually in the boot hill of New Mexico. As my introduction said, it is Bortle 1 skies, which means there's practically no light pollution. Rusty at Rusty's RV Ranch is very adamant about keeping the RV park friendly to astronomers. So part of the check-in process is white light after dark. When you're driving in, parking lights only. And if you need to walk around, you need red light. If you need red lights, she has them available at the check-in office. So you got to prep the location. You got to clear out the land, make preparations for the foundation, and contrary to visual appearance, this is not a pet cemetery. So you got to set the foundation and pour a footer for the pier. I basically did all this work with the help of some of the others I mentioned at the beginning. The footer for the pier is about 2 tons of concrete that I hand mixed in that wheelbarrow that's in the background and poured into the ground and into a form. And then I used all thread in the very top of it so that I could anchor the pier to that footer. So you need a building. There's lots of options on this. You can buy a completely prefabricated building. You can hire someone else to build a suit or build your own. And you got to decide up front if you want a roll-off roof or a dome or a clamshell or any other type of roof opening. I personally opted for a roll-off roof. It's a lot easier to construct and it provides rapid cool down of the interior. So your equipment be in temperature very quickly. It's more incognito as well. When it's closed up, it just looks like a building sitting in the middle of nowhere for no apparent reason. Unless you know what you're looking for or looking at, the roll-off part of it doesn't even draw your attention. So this building that I got was from Graceland Portable Buildings. And so it came prefabricated as a shed that you would use for storage in your backyard or whatever. So I bought this specific design because I knew the roof was the same level all the way around at the top of the walls. So it would be easy to split and modify into a roll-off roof design. In this picture, it's probably a little tough to tell, but you can start to see light coming through right between those two top of wall header boards. We started trying to use like a metal spud bar or something to drive between there, but we found that it was just deforming the wood. So we ended up using pine shims and driving the pine shims between the two 2x4s at the top of the wall. And that gave us a lot better success. It actually started separating the wall instead of deforming the 2x4s at the top. And, you know, just getting started, and we already have things up on blocks here. So what we did was once we got top of the wall split just enough, I used a Sawzall and put the Sawzall blade through between the two boards to cut all the nails. It turned out whoever was in charge of the end walls this day was extremely nail happy compared to the person who did the side walls. On the end walls, there were about 16 nails between each of those 2x4s for the vertical wall boards. And on the side walls, there was only about 3 between each of the vertical studs. So since we started on one of the end walls, we thought we really had a long road ahead of us. And then it got substantially easier on the sides. And then we finished off with that complexity again of all those nails. So once we actually had everything cut, we used a jack and that 2x4 with the level, that orange level in the background here. So we made sure that the 2x4 was vertical, and then we put the jack underneath it and started to lift the roof. And that's how we got these these blocks of wood under. And we started with these blocks of wood flat, so it was only the thickness of the 2x4, so 1.5 inches. Then once we got that done all the way around, then we lifted it up a little bit more and stood them on their edge, so it was 3.5 inches. And then once we got that done, we lifted one last time to this 6-inch spacing, and that's where we left it for the rest of our maintenance and conversion. So unfortunately, you can't do all this in one day. So we had to be able to secure the roof for nighttime when we're leaving it unattended. So we ended up using these scab boards, which was just OSB. It was about 3/8 of an inch thick or so. And I just put about 5 or 6 screws through on the top rail of the wall and the bottom rail of the roof. We did that in about 6 locations, 3 on each side, and that was plenty to hold the roof up while we did the rest of our work and keep it secure overnight. Then we started to do the rollers. I opted for a V-track design and bought rollers with a V notch in them. To affix this, we actually put the rollers on a new 2x4 on the ground, and we centered them and made sure they were straight. And then we flipped the board upside down, or right side up, I guess it is, so that the wheels were down, and slid it up in under the roof while it was held up by those OSB scabs. And then we screwed down through the existing roof board into this new roller board that we'd created. So it both reinforced the bottom of the roof board itself and let us get our rollers underneath it without having to fidget and try to screw the rollers up into it from the bottom while it was still above the wall. So it made things really easy to get things installed that way. Also in this shot, you can see this piece of metal hanging off. So under the rollers, we started with 1/4-inch plate steel that was 4 inches wide. So that's what sits on top of the wall of the shed itself. And that gave a real nice smooth rolling surface for while we were working on this. And then one of the other things we did, we only put the V-track on one side. And what that allowed for is the roof will stay aligned by that V-track and roll easily, but any twist in the roof won't cause it to bind. So if you put V-track on both sides and there was any twist, you'd have rollers pushing against the sides of the track, and you could get a bind situation where maybe your motor's not strong enough to actually overcome that. So instead, we left V-track off of one side so that the rollers are only running on top of the plate steel, and so they're free floating to adjust as they need to as things shift back and forth. And I see there's some chat going on. Are there any questions or anything at this point?
No, I think we're okay. If you
Okay.
can hear me.
Yeah. You're good.
Great. All right, we'll keep rolling. So now that we have the roof on rollers, the next thing is to set up the rails that the roof rolls off onto. I oriented the observatory so that the roof would roll off to the north, and that would give me a good clear view of the southern sky where there's a lot of nice things to photograph, especially when you're down in the southern part of the US. So we made sure that the rails were level, and then we temporarily suspended them with these kickboards, basically. And we used clamps at the top between 2 pieces of that OSB, just so we had some movement. We could level things and get them not only level, but parallel with the actual sides of the observatory. And then once that was in place, I hung a plumb bob down to point to where the post needed to be. And then we dug a hole out underneath the rail, sat the 4x4 post down in it, and then screwed it to the bottom of the rail, and then poured concrete in around the post. So I didn't have to worry about, are my posts 100% true? Are they twisted? All that stuff was taken out because I affixed the rails first and then hung the post down from that. So it made really quite a bit easier installation than if you're on another route. I also opted to have a flap on the south part of the wall for the roof. And the reason I did this is I wanted a clear view of the southern sky, which isn't necessary for a flap, or it's not necessary to have a flap for that. But the big benefit is the roof can move no matter what position the scope is in and not worry about impacting the scope. You definitely want to have fun along the way. It may be tough to tell, but in this shot, I have a mohawk. So this was even before COVID, and I was already goofing up my hair. So once the concrete set and we took down the battery braces, we let the roof roll out onto the rails for the first time. It was actually so easy to roll the roof, it was a little alarming. We rolled it off, and Mark, the gentleman that helped me most, he and I stepped back and were admiring our efforts and our success. And it's just this light little breeze, maybe 1 or 2 miles an hour, kicked up, and the roof started rolling on its own. So we jumped under it real quick and put some clamps on it to hold it in place. It was one of those, like, it wasn't going to roll away immediately, but if the wind had picked up much more, it would have been a big problem. Here you can see on the south wall, the flap is now on hinges. So it's hanging down upside down there. And I've got my solar panels there supplying us with power while we're doing the build. And speaking of power, so because it's a remote location, getting residential power put in would have been quite a hassle. It was available at the RV park, which was probably about 1,000 feet away, and it's on the RV park property. But I opted instead to go pure solar. I like the self-contained nature of it. I like the fact that I don't have to worry about power going out in that area and not being able to close the roof and protect the equipment. So I went with 4 basically 300 watt solar panels. So I have equivalent of about 1,200 watts of solar. I have 2 Tesla battery modules. So Tesla electric vehicles, specifically the Model S and Model X, have 16 modules that make up the floor of the vehicle and provide power to the electric vehicle. These are available aftermarket through like scrap yards and different wholesalers and such, that they buy wrecked Teslas and disassemble them and sell the parts. So I purchased 2 5.2 kilowatt hour Tesla battery modules, and each of those modules have 444 lithium ion batteries in them, which is about the size, a little bit bigger than your thumb, basically. It's called an 1850. So that gives lots and lots of power. Basically, even if it's completely clouded out for 2 weeks on end, there's still enough power in the batteries to run the observatory for that glorious clear night at the end of that 2-week stretch. I also used a TriStar MPPT solar controller that's able to charge the batteries at 60 amps under full sun. And this is what the Tesla battery modules look like. So these are the 2 modules. They have rails on the sides, so I ended up cutting a slot into 2x4s and clamping them down onto the rails that are on the sides of the battery, and then anchoring that to the wall. You can see I'm running them in parallel. These are nominal, basically 24 volt packs. So I also need to convert that power down to 12 volt for most of the observatory. And that's what this box is. Just off to the left-hand side there, you can see that blue box vertical. That converts the 18 to 25.2 volts that the Tesla modules output down to an adjustable output between like 10 or to 16 volts. I have it set at 14 volts, so it's at the upper range of what most 12 volt equipment runs at, but it also keeps the current level down and makes the wiring and everything more efficient. This box on top here with the gray bottom and the black fins, that is my solar charge controller. And I just realized that my screen was dimming. Night mode was kicking in. Sorry about that. So that charges the batteries through the solar system. This module at the bottom is a battery protection device. So if the battery voltage drops too low that it could be dangerous to discharge further, it will disconnect all the discharge loads, but leave the solar hooked up so that it can recharge the batteries. And then this is an inverter that converts the 12 volt or the DC power to 120 volt AC. Nothing in the shed runs off of this. It's purely there for my convenience when I'm on site, so I can run a vacuum cleaner or a grinder or whatever is necessary.
There's a comment. I'm
Sure.
not sure. I don't think it's a question, but it's from Mark, and he says, "Hams, I listening to Carolina 440 DN4MQU. Does that reference to your batteries? I'm not sure exactly."
He's basically saying
that's a message to us ham radio operators that are on the Zoom.
Oh, okay. Oh, well, never mind. I thought maybe it had something to do with your batteries.
Oh, no,
I'm sorry.
yeah.
Okay.
No problem. Just going on across in this view, this box is a weather station receiver for an astronomical weather station. So it can sense clouds, sense condensing moisture. It has wind speed and direction as well, but I don't use that part of it, and I'll talk more about that in a minute. And then this box on the bottom is a network controllable DC switch. So it provides 5 Anderson power pole outputs. And so those can be turned on and off across the network. So I can power cycle things if I need to get them back online. And then this is the internet gateway computer. It's kind of tough to see, but it's just a little tiny box. Doesn't have to be very powerful. All it's doing is routing internet traffic. This box is part of my roof control system that I designed. It's actually a Raspberry Pi with a CAN bus interface. So I opted to use CAN bus for controlling the roof and the south flap because it's a robust interface. It's not susceptible to noise, and it just works. You don't have to worry about packet loss or anything like that. It's a simple network, and it works really well. 3 network switches across here that connect all the network gear, another weather receiver for an ambient weather station. And I use that because it's much more accurate for the things that it measures: wind speed, direction, wind gust, temperature, solar radiation levels, UV, all, rain rate, rain amount, all that stuff. It's much more accurate than the astronomy weather station. And yeah, so the rest of this, there's a little computer for controlling the security cameras and stuff I have set up. And then cellular booster for when I was using a Verizon link. Now I've switched over to AT&T because they just lit up a tower, so that's no longer used. And this is pretty much the completed shed. You can see the 4 solar panels here, so 2 on the ground and 2 on the building. I had originally thought I was going to get away with just the 2 on the building, and in the wintertime it gets cold enough that I need to supply heat for the Tesla modules. Lithium ion cells, it's actually damaging to the cells if you charge them below freezing. So I have a heater element in there and a loop of coolant that flows through the batteries and keeps them warm. And so I found that on really cold nights, just the 1 battery module and 2 solar panels would get down to about 50, maybe 45% capacity. So I didn't feel quite comfortable with that margin of error. So I doubled my solar panels and doubled the batteries to the 4 panels and 2 batteries. So how do we roll the roof? I opted to use a number 40 chain. So this is very similar to what's used for like a motorcycle chain for driving the rear wheel. It's also used in a lot of industrial applications and farming equipment. I built all of this actually. So this is 1/4-inch plate steel, and then it's bolted onto a 2-inch tube steel square tube stock, so that the chain runs across a sprocket here, up, and is connected into the roof, and it's screwed through the chain and then through this plate steel up into the wood structure of the roof itself. So that's how it maintains control of the roof. Then it continues on this 2-inch tube steel all the way out to the far end of the roll-off roof. And at the far end is another one of these sprockets, and then the return of the chain comes inside the tube. That's a lesson learned from fellow astronomers that have observatories. If you leave it outside of the tube, over time gravity stretches the chain, and you'll end up out in southern New Mexico. You'll see a lot of observatories where they have this chain that's just bellied out all the way down, touching the ground. So by keeping that chain inside the tube steel, it protects it from that. Then the return comes up over this sprocket inside the bottom part here and down around the drive here. So this is a 60-to-1 reduction gearbox, so that it makes the torque of DC motor much higher and gives it plenty of power to actually move the roof. And then also slows it way down so that it's not racing down to the end of the shed. And then it's connected via this belt to a 1 horsepower DC motor. And the motor is 24 volts, so it runs at the same voltage as the Tesla battery modules. So it can get plenty of current to maintain that 1 horsepower if it needs it. And it's, after I put it in, I talked to the gentleman whose shed I patterned this off of a lot, and he chuckled. He only put 1/4 horse motor on his. So evidently I went a little overboard with the 1 horsepower. This is the control system that I put together for the rolling roof. This main board here with all the MOSFETs and the heat sinks is a reversible variable speed DC motor controller. Normally it comes with a switch that has a center off and then a forward direction and reverse direction on that switch. And then also this little dial lets you adjust the speed of the motor and enable or disable movement altogether. So I cut into the switch that controls forward, backward, and enable disable, and I pipe them all into these 2 relays. So one of the relays controls whether motion is enabled or not. So it's either on and moving, or it's completely off, and it doesn't matter what direction you have selected. The other relay controls whether it's forward or reverse, or open or close in my case. So it changes the direction of movement first, and then it energizes movement through the other relay. That's all controlled by this little Arduino Nano. And then this is the CAN bus interface that allows it to talk with the south flap and the control computer. And then this is just a bigger overview. You can also see up here, there's 2 limit switches. Use 2 limit switches on both the fully closed position and another 2 on the fully open position. And one of the limit switches actually disconnects power from the motor. The one sends a signal to the microcontroller. So if the microcontroller fails and doesn't disable the motor when it's fully closed, the other limit switch will de-energize the motor anyway. So it double protection in case something fails. Same for the open direction. So in the fully open position, I didn't want to have wires and sensors outside of the shed in the weather all the time. So I took one of the pins out of this chain and I put a grade 8 bolt through the chain so that it stuck out the side. And I positioned that pin so that when the roof was fully open to the position I wanted it to be, that pin would push down on these limit switch actuators. And that's how I know when the roof is fully open. Again, 2 sensors or 2 limit switches, one for the microcontroller and one to de-energize the motor so that it fails safe if something happens. On the inside, I insulated the interior of the roof, and I insulated the walls as well. And in this picture, you can see this plate steel. This is, again, 1/4-inch plate steel, and it has a hole bored through it. And then on the flap itself, there's a 1/2-inch grade 8 bolt that comes through the flap. And what this does is when the flap is closed and the roof comes together to meet the flap, this plate steel threads over those bolts so that it provides hold down strength for the roof itself so that the roof won't get blown away in high winds. And here's another shot where you can see a little better. So this is partly opened. You can see the plate steel and then the bolt coming through the flap there. I duplicated this on the north wall as well. So it holds down both on the south wall via the flap and the north wall from the wall to the roof itself. Very similar setup to the rolling roof part, but this is for the south flap actuator that opens and closes that flap. This one, I don't have any limit switches because the actuator itself has internal limit switches, and it provides a pulse output that accounts for every pulse is a certain amount of distance that the actuator is moved. So I'm reading that into the Arduino and making it available to the code. So it knows exactly how far the flap has opened or closed. And then the internal limit switches stop, and it knows then, because it stops receiving pulses, that the actuator has stopped motion. This is the outside interface for the actuator for that south flap. I found that the flap is a wear item since it's out in the sun all the time and in the rain and elements. I've already had to replace it once. So when I replaced it, I just chopped the cable on the outside and put in this junction box. So in the future, if I need to swap it out again, it's easy to manipulate instead of having to, put a new wire through the wall or something. And this is the actuator itself. And this one is a 12-inch of movement that it will actuate. And it has a 330-pound capacity to lift or pull. So it's plenty of power to move the flap. Here, because I had to replace it due to the weather, I decided to try to weatherproof it a little bit. So I used a Coke bottle and cut the end off of it and stuck it down over the motor. It's a nice tight fit. It's not blown away, and gives some marine protection to the motor. This is the shed fully opened up. The roof is all slid back, and then the flap is down, as you can see. And there's the solar panels. And then this is an all-sky camera that I built for the observatory as well. So even if it's a cruddy night and I can't use the equipment inside, I still have my all-sky camera doing time lapses. And even when it's a thunderstorm or something, those time lapses are really pretty neat to look at. Another shot at night, or just dusk, getting ready to be night. The sun is setting over the Chiricahua Mountains back there, and you can see, I think that's probably Venus setting there. There's an aerial shot, so you can get a better overview. Gives you a good view of the rails and the whole construction of the system. It looks a little odd sitting in the middle of the desert if you don't know what it is, but not odd enough to scream that there's thousands of dollars of equipment inside that you should, kick the door in to go check out. And after I built it, I realized that it was coming up on galaxy season, and 120 millimeter refractor just wasn't going to cut it. So I got a really good deal on a used plane wave 12.5-inch CDK. And so now I think it's 2600 millimeter focal length, plus or minus. It does pretty good for galaxies and all the little faint fuzzies out there. What about internet? What good is it if you can't get access to it? So it is remote, and the local internet service is DSL, and it was 10 megabit down, 1.5 megabit up. It was $70 a month, and horribly slow and unreliable when I was there. So that was kind of a last resort. Verizon Wireless had installed a tower a couple of years earlier, well into LTE deployment, but they opted to put a 3G tower in. So that wasn't exactly super speedy either. Luckily, about 6 months after the build, AT&T stood up an LTE tower, and now I was getting 40 megabit down and 15 megabit, which is absolutely awesome for doing remote observatory. The download isn't really even of much consequence. The upstream is really what you're interested in for the remote observatory, because you're using the computers there and they're sending their screens or views, whatever, back to you. And then when you capture data, you need to upload data back. So one of the benefits that I have is I put a computer that's powerful enough to run image processing software that also runs the scope and the camera gear. So I actually remote desktop or Chrome remote desktop or TeamViewer or VNC. I have all those at my disposal in case one of them fails. I can actually connect into that computer remotely, load up all the from the night, and do preliminary processing. So calibration and stacking and all that stuff. I can do all that remote on that computer and then only upload the master image to me so that I can do the final tuning and tweaking on my local system where color accuracy is more important. But does it work? Yeah, I'd say it works. It does all right. This is the dumbbell nebula that I captured through that setup. The camera itself is a ZWO ASI 1600. It's the monochrome camera, the 7-position filter wheel. This image was taken with just RGB. So there's no luminance, there's no hydrogen alpha kick to boost any of the light or colors or anything. And it's dark enough that that's just fine. I don't have to do any real narrow band work at all. Again, Bortle 1 skies, it's actually what sold us on this location. We were there at the RV park just to scope out the area and try to figure out if it's where I wanted to put an observatory. And we had booked it for 1 month. The third night in, I took our dog out to walk right before bedtime. It was about 11 o'clock at night. And I was walking around and I could see perfectly well. And I was kind of baffled because I knew it was supposed to be a new moon. And I look around and sure enough, there's no moon in the sky. But the light from the Milky Way and the stars was bright enough to actually walk around without tripping over anything. It was just completely mind-blowing. And the Milky Way was just looked like it was painted across the sky. So we extended to 3 months, ended up building an observatory and being there for 5 months to get it all completed. What about safety? So you've got a lot of investment in your equipment there, in the observatory itself, the computer gear, batteries, solar, all this stuff. So to that end, I have dual weather stations, as I pointed out earlier. I have one that's specifically for astronomy readings, so IR sky temperature, IR ambient temperature. It does speed and direction. It also does condensing moisture levels. I know if there's condensation or dew coming down. So that gives me a lot of data. Then the other weather station is wind, speed and direction, temperature, solar, all that kind of fun stuff. So I have these 2 weather stations and I combine both of their data. If one fails, then I can rely on the other. Even though it may be less accurate, it'll still at least give me something. And there's multiple points of safety enforcement. So multi-point is safe. I created an ASCOM alpaca interface for the weather system and for the safety signal, and that gets typed in via ASCOM to Sequence Generator Pro. So the imaging computer itself knows, based on the information it's receiving, if it's safe. The safety monitoring system itself that interfaces with the weather and everything, it actually tracks the safety as well, because it's the one that reports to SGP. And if the weather system goes out of bounds, then it will close up automatically, even if there's nothing on ASCOM telling it to. So there's 2 points of safety. The roof, the flap, and the main control computer, they're talking over this CAN bus, and they're sending a heartbeat signal every 1 second if any device on the network misses for 15 seconds a signal from one of the other devices, then it will automatically close the roof and the flap. Whatever's still accessible, it will take it upon itself to send that signal to the other end to close, and then it itself will close as well. So there's 3 levels of redundancy for the safety at this point. And then, as I talked about earlier, the redundant limit switches, so that the roof open close positions are fairly strictly enforced. So there's double enforcement on that. Lessons learned. So what would I do different? The first is I would pour footers instead of placing concrete block in the ground. That turned out to be incredibly difficult to maintain level of the concrete blocks. And in the desert, metal is better. It holds up better to the elements. And I would probably actually go with stucco instead of a finished or stained wood product for the outside of the building. Basically, every 6 months when I'm out there, I end up doing touch-up work, just general maintenance to keep the shed weatherproof and everything. It is a little windier there than I expected. It does settle down overnight, so I'm able to still open the roof safely even at night. But a little bit better wind resistance would have been to go with a captive roof design for the rollers. So in that setup, there would be a plate over the outside and then a roller underneath, like an I-beam, so that the roller is pushing down on the bottom most of the time. But if the wind kicks up and pushes, it gets caught by the upper part of the I-beam. So it would be less susceptible to high winds when it was open. Or possibly use a dome. A dome gives a lot better wind protection of the equipment and lets you image in much higher winds. Also, no matter how hard you try, bugs or critters will get in. I've heard a lot of horror stories of people with mice and rats that move into their observatory while they're not there. I've been lucky that I haven't had that part happen, but I have had a lot of bugs. And things will fail. So yeah, so I'll turn this up so you can hear it. So that happened when I was working on the automation of opening the roof so that it would all fire automatically via ASCOM commands. And I was in Las Vegas, which is about a 10-hour drive to the observatory. And working remote, I had that video feed up in the background. I had fully tested the roof opening and closing by itself. Everything was good. I'd fully tested the flap opening and closing by itself. That was all good. So here I put those 2 pieces together. What was supposed to happen was the roof was supposed to roll away for at least 30 seconds and then the flap would open. What ended up happening is the roof just hiccuped a little bit, about a half a second, and then the flap tried to open. And because of those bolts interfacing with that plate steel, it couldn't open. It was locked together. So until the roof rolls away from it, that flap can go nowhere. And it turns out 330 pounds of force is plenty to break a 2x4 in half and pull all the lag bolts out of the knee board that was holding up that area. So I made an emergency drive over the weekend, straight through the night with tools and everything on board. Got down there. Luckily, it broke the 2x4 board right at the wall, so it didn't destroy any of the interior structure of the wall. And it didn't destroy the flap itself. It didn't pull away from the flap. So it turned out to be a fairly easy repair. I just needed to unscrew the interior boards, bend those away to get in and loosen the anchor bolts that were inside the wall holding that kickboard out, and put in a new board, put it all back together, repaint it, reseal it, and I was done. So it took me about 3 hours. And yeah, about 20 hours of driving for a 3-hour repair in the middle of the desert. And then I mentioned bugs. You may be able to tell there's a lot of speckles here on the ground. So early this spring, when we went back to that area to do just the general upkeep. I opened the door to the shed, and it looked like a scene out of Alfred Hitchcock with all the moths just come pouring out of the door at me. That happened 2 more days until my Amazon delivery of bug strips arrived with insecticide. And you can see one hanging up down there and one hanging right here on the bottom of the roll-off roof storage area. So I put those 2 up, walked away, came back the next night, or the next day, and all of them were dead, which I was very happy about. Unfortunately, they were moths, and I don't know if they just, in their dying, they put out some sort of goop or something. I'm not exactly sure what it comes from. There's the pile of them I swept up that day. So those each section of those tiles 6 inches. So that's a 12-inch, basically diameter pile, about 2 inches high of all those moths. They were very fuzzy. So in flying around inside my observatory, they got moth fuzz all over the OTA, which actually turned out to be the least of my concerns, because they also got into the OTA, and this is, I don't know, some sort of moth guts on the primary of my 12.5-inch CDK. So I got to completely disassemble my CDK and all my imaging train. And thankfully, my coach, I have reverse osmosis water, and I have deionization canisters, so I could produce my own highly purified water to clean it with. And it cleaned up really well. I was extremely surprised that there was nothing etching about those bug guts that were on the mirror. So what about controlling and feedback and information about what's going on in the shed? So again, if you haven't figured it out, I'm a little bit of a geek. So I created my own user interface to show battery level, battery voltage, how much current flow in or out of the battery. It shows the status of my solar. So this was doing an absorption level charge. The LED on the front was green and blinking. There were no alarms and no faults. This is the BMS data directly out of the Tesla battery module itself. So they have what's called a battery management board built onto each module. And so this is the voltage readout of each of the cell groups inside of both packs. So you can see, I don't know if you can see this on the screen, but 1.1 through 1.6. So that's the first module, 1 through 6 cell groups, and then the second module, 1 through 6 cell groups. Minimum, maximum, the delta between highest and lowest voltage level, the average, if there's any balancing going on, because they have balance resistors built into the board that I can trigger if there's a cell group that's higher than the rest and it needs to slow down charge on that while it charges the others up to match. In the 2 years that this has been running, I've never had to balance a single cell. So the Tesla battery modules stay very, very well balanced. And then here's the output power from the solar. So the panels in this screenshot were producing 111 watts, and it was 110 watts of charging batteries. So it was a 98.8% efficiency of the solar panel conversion into battery power. And then the shed itself as a whole was using 3.8 amps. And then these are the temperatures of at the positive and negative terminals of the batteries. So this was kind of a warm day. They were about 100 degrees on those posts, perfectly safe for the lithium ion. So I can monitor all that remotely. And then I mentioned that DC load center that I can toggle power on and off. I actually have 2 of them. The main one is the one that was on the wall, so I can reboot my imaging computer, reboot my gateway computer, power cycle all the control surfaces, so the Arduinos that are running the flaps. I can turn on lights inside the shed. I have an LED strip. And then this is the Skymaster Pro. This is the weather station for astronomy, so if I need to power cycle that. Then riding on top of the scope, I have another one that controls power to a USB hub, my imaging camera, the night crawler, focuser rotator, the Delta T, which is the internal heaters of the plane wave, and the electronic focus adapter for the plane wave, which I'm not actually using, except for some reason plane wave puts the fan controls through that. So I have to run both the delta T to heat the tube and then the EFA to actually cool the tube and cycle air through it. And each of those I can get a current reading, how much power it's using, what the supply voltage is. This one was actually locked up. I should have rebooted it before I took this screenshot. That computer does not use 12 amps of power, and my voltage was not 19.99 volts. It was actually 14.05. I also have a flat panel from Spike, and that I can control here. I can set it to my flat level of 100 out of 1,000, or if I want to adjust it manually, I can adjust this slider up and down to change the brightness of the flat panel.
So we have a question.
Sure.
How many square meters of solar panels do you have?
Square meters.
That's the question. Or maybe you could, if you have it in square feet, I suppose that'd be this, you know.
Yeah, I'm doing the math on the actual size of the solar panels. They are 39 inches. No, 30. Crap. I'll have to look up the specs on it.
Okay. All right.
I'll get back to that one. Yeah, it's they're residential panels, so they are fairly large. They're large enough that you can grab them together with both hands and move them around, and they're about as just shy of as tall as I am. So I think they're 39 inches wide by 59 inches long, if memory serves.
All right.
Yeah, each, and there's 4 of them. So yeah, let's see, 39 times 60.
If you want to look it up, you can. You don't have to do it now.
Okay.
They sound like they're a little under 2 meters each, and you basically got 8 meters of panel, but you're only getting about 100 watts. That's not great.
1,200 watts.
1,200. Oh, that's great.
Yeah. Yeah, 1,200 watts of power. So yeah, they recharge even on a cloudy day. They actually recharge the overnight power usage of the modules, usually by 12 or 1 o'clock in the afternoon. So it'd have to be extremely dark and stormy for a long time before I'd have to worry about the batteries being depleted. And actually, the lowest I've ever seen the batteries in this configuration was 39% capacity.
Wow.
So yeah, they do a good job. And then this is my roof status and safety system. So here, there's the master. Is it safe to open the roof? Yes or no. Green for go, red for stop. I can force it to be safe if I'm doing maintenance and I don't want the roof to close up on me while I'm working on it. And then the voltage that the rain sensor outputs, that's my threshold of if it's condensing enough to lower the threshold or lower below 3.4 volts, then I close the roof. The cloud delta. So the way the cloud sensor works that I'm using, it has an IR temperature sensor pointed at the sky and one pointed ambient internal. And when the sky is clear, the sky IR temperature is extremely cold. So you should have a really high delta of sky temperature to ambient. And the closer the sky temperature gets and warms up closer to ambient, the more cloud cover or moisture you have in the air. So for my particular use, if it's less than 25 degrees Celsius delta between the sky temperature and ambient, then I consider that too cloudy to operate. And then
So,
if it gets,
so if I don't know if they have like sudden rainstorms, but do you have a sensor for if it, I don't know, if it just like popped up really quick and your cloud sensor didn't, get all of its data or something and just like, and it started pouring? Do you have anything that looks at that?
Yeah, so this rain voltage, it's actually a coil of two copper traces on top of the board. And as moisture increases, the voltage read across that coil drops. So even if it starts condensing like just dew in the atmosphere, that rain voltage will drop down low enough that it'll close up the roof and protect the gear.
Okay.
Yep. And then wind speed and wind gust. So those are the things that I measure to determine if it's weather-wise safe to open the roof. And then I can do manual overrides of roof and the flap individually. So if I need to do maintenance on something and I want to just open the roof enough to and then open the flap to be able to work on something, then I can do that manually. Otherwise, the safe open, close, and stop, that takes into account the safety outputs. So that goes through the whole ASCOM control system and everything to exercise that.
So Michael, in those the wind categories, just making sure. So the threshold there is 16 miles per hour, constant speed, wind gusts of 18.
Correct.
Okay.
And it's probably overly conservative. I know I've had the roof open in 25, 30 mile an hour winds and nothing has happened. But at that point, you've got your OTA out there kind of, you know, it's probably getting buffeted by the wind anyway. So it's more comfortable to me if I leave it that conservative. I also have security cameras all the way around the outside, and then I have 2 cameras inside, one at head level facing southeast, and then one on the floor facing up at the actual scope and mount and everything. So I can actually turn on IR outputs on the camera so that I can see in the dark if I need to, or I can also turn on the light inside the shed if I need to. And then this is another view of all the weather statistics and data that I get. This side here is all from the ambient weather station, and then this side is all from the SkyMaster Pro. So I can see at this point, yeah, this was daytime. So the naked eye limited magnitude was negative 4.9. At night, it's usually maxes out about 22, 23 for the naked eye limiting magnitude. So it's, again, a very, very dark site.
Do you have you photographed any animals?
I have.
Have you?
So,
Okay.
yeah. While I was actually, I was there finishing up the initial setup and everything, I came out one day and there was yellow snow. And it did snow. It does snow in the desert. This is like 4,000 feet elevation, high desert in the southern part of New Mexico. And there was yellow snow. So I was curious what gave me some yellow snow. So yeah, I went back in the footage and found a rabbit had hopped around and done his business and hopped off. The rabbits, it turns out, are not all amazing. I actually had one bite through the network cable that was feeding my all sky camera. So it's power over Ethernet and data over the same network cable. And just one day my all sky camera was offline and I couldn't power cycle it and bring it back or anything. So we were due to be on site within 2 weeks. So when I got out there, I was chasing everything down. I opened the camera up, checked everything, no water ingress, everything was good. And finally I was like, okay, well, I got to pull up the network cable. I went to the shed side and started down the wire, and right there it was chopped almost entirely in half. And it's direct burial rated cable, so it's pretty tough stuff.
There was some sort of telescope or something that was remote that was in it was either in Antarctica or or in Alaska, and it was attacked by snow bunnies.
Oh wow! Yeah.
Yeah, I mean the wires were. I mean, obviously not the entire telescope itself, but the wires were.
Oh yeah, they for some reason. My only thought is I didn't have this cable connected in with the rest of the bundle that I had coming down out of the shed, like to go out to the solar panels that are out on the ground. So my theory is the rabbit was sitting there and the wind was blowing and causing that network cable to flap a little bit, and he got tired of it and just bit it, I guess. I don't know. I have the video showing him hopping into that location, the all sky camera going offline, and then him hopping away. So I know when he did it exactly, but I don't know. This is another view I have for cycling power and managing things. This is through a home automation software, just another way of doing things. And it's at Rusty's RV Ranch in Rodeo, New Mexico. And I'm Michael, and
I'm Lehnanne.
Lehnanne, my very, very understanding spouse.
Yeah, I'm a stargazer. I'm not really into the technical side of it. I like the end result, but when he first started getting into astronomy, I tried to remind him, most of that happens at night, right? And he likes to be in bed at a certain time. So
Yeah.
having the Astro Shed and having it all on automation, it allows him to wake up and then start, it all takes care of it. Where I just want to sit out and look at the stars. And so we balance each other a little bit.
Yeah, it is fully automated. I can actually create my entire imaging plan in Sequence Generator Pro and connect all the equipment and click go, and then go to bed. And I can do that at noon if I need to or want to or whatever. I don't know why I'm going to bed at noon, but it's possible. Then when the object gets high enough in the sky, it will check the weather conditions, and if everything is safe, it'll open the roof, slew, plate solve, recenter, rotate the camera if need be to get the angle I'm looking for if I'm doing multiple nights of exposure. It will do all that stuff automatically, focus, do the imaging run with guiding running and everything. If at any point things go out of spec, it'll close up the roof, it'll park the telescope and wait for things to go safe. It'll recheck every 5 minutes for up to an hour and a half to see if things go safe again. If it does, it'll reopen and take back off again. So
we had 2 questions.
Sure.
First of all, the first question, I'm gonna read both of them and then you can decide which order you want to put this in. But can we see a demo of the scope right now, if that's possible? And then is it possible to get any kind of insurance for your equipment installation? In other words, do you have your installation or your shed and everything insured?
So yeah, I'm actually leasing that land from Rusty's RV Ranch, and basically I'm able to get a renter's policy, and then I put on a like a high expense kicker on it to cover the cost of the gear. So yeah, I was able to get the insurance on it. I've never had to file a claim. According to the insurance agent, that should be fine. I hope it's fine if something happens, but I've never had to test it. And wow, a live demo. Yeah.
Well, I'm not sure we might have time for that. I don't know what the time frame is to load it. But I would say, think about that. But we do have a couple other questions.
Sure.
Is it even dark enough in New Mexico right now?
I can show
not.
you the outside and show you the scope, maybe.
So there is another question from Betty Ann. From the day that you started with the footers till the day you figured it was complete enough, because I'm sure it's never going to be complete. How much time elapsed?
Months.
Yeah. So I took the entire month of December off from work to do most of the work, and that was able to get to about the 80% mark. And then I spent the next 3 months doing the remainder up to the point where I felt safe leaving it physically. And then I did the automation coding remotely. So I had the code flashed to the controllers, the roof controller and the flap controller. And then I did the rest of the automation programming remotely, as you saw by my my breaking of boards. It didn't go 100% smoothly, but yeah. So all in all, about 4 months total from start to drive away and then finish up some code someplace else.
But that also included a day job. So
Yeah,
Monday through Friday during the day, he was working and then piecemeal getting it together.
Yep. So I'm working with OBS to get a view set up so that I can show
Do you
something.
want to put my camera back? And does anybody have any questions for the spouse? Like, how patient did I really have to be?
So that is.
How patient were you? I know my husband has hobbies. He's not an astronomer, but he has hobbies, and I'm like, do your thing.
Yeah, my hobbies are not as expensive. So there was a lot of talk about the budget, and I had a hard stop on how expensive it was going to be. So we were very communicative on that. Luckily, I like the nights, the dark skies. I like being out in the middle of nowhere, and being in the motorhome, we're self-contained, so that's not a problem. It's really good to be a hermit when you're, you know, doing these kind of out in Bortle 1 skies. They don't tend to be anywhere where civilization is. So I enjoyed that. It wasn't anything that bothered me being out away from civilization. There's a lot of nature out there that I could just get in the car and go wander around. So it really wasn't, I really didn't have to be that patient. It was really well thought out on his part. He had all of the details down to, you know, the penny, what exactly he needed. The biggest adjustment was having to put my foot down, going, we are going into town and having a date night. You know, 5 weeks of middle of the night out there banging with boards and getting things together. You need to step away. That was the only time I really had to put my foot down, was I need a steak dinner. So let's go into town. So,
That she didn't cook.
that I didn't cook.
Or I didn't cook.
He doesn't cook.
So any more questions for her? I do
Yeah.
have it set up so I can view the web a little bit.
We'll let you go and do that. So thanks, guys. I'm gonna disappear.
Thank you.
Uh-huh.
Yeah.
So let's see here. Okay. So this is the interior. That's the one looking up at the scope. And right now it is not dark yet in New Mexico. It's only about 6:30 at night. So I'm going to switch tabs over here. This is live. So the batteries are 98.5% right now. The shed is drawing about 5 amps of current. And let's see here. We'll go to the power system. I'm going to turn on an LED and we'll switch back over here and buffer. There we go. So that's live view inside the shed. Live demos, guys. You're it's working. It's working. Let's see. Do I brave opening the roof? Let's see what how things look right now. Yeah, it's pretty calm. Okay. I'll open the roof. Why not, right? I don't know if you heard that little chime, but
Yeah.
I get notices every time something moves in the shed. And I can turn on audio. This camera is really loud because it's right next to the motor and everything. Let me switch to this view. And it did not stop. It's just buffering video. Still buffering. There we go.
I imagine that can be at times, heart dropping.
Yes. Yeah. If you're well, and so while that whole board breaking thing, I had the video feed of that up in the background, and I clicked go, but I was dumb and didn't have a cancel button right there ready to stop things. So I could hear the breaking in the background while I was trying to type a command to stop the roof from moving.
Mm-hmm.
So it was just gut wrenching hearing that wood splintering and everything. Yeah.
It did help to
bad.
have people on site there at the
Yes.
RV park that have some astronomy intelligence, I guess, or experience. And so we were able to get a friend to run out there really quick and, do we need to have somebody go fix it right now, or can he drive down and do it himself? So it's very handy to have it at Rusty's, where there's almost always an influx of astronomers.
And that was what I was going to ask, if you had a trusted on-site resource that, if something went sideways here, they could go over and manually push the roof shut or something like that.
Yeah. So that brings up a really great point. One of the options I looked at for actually moving the roof was an all-in-one worm drive reduction gearbox, and it would have been the motor and the gearbox all in one, and then just the let me switch to the other view so you can see the flap going down. And it would have worked just fine, but, and again, the video is buffering here. Oh, you can't see it. Dang it.
So while we're waiting on that, I know there was another question from Matt.
Oh, go ahead.
You know, that has anyone else set up a shed? He sees that Rusty's is looking to lease a bunch of lots dedicated to astronomy.
Yeah, I'm the first, and so far still the only. Actually, I take that back. There was one other that had been out there before I came on site, and I think finances or health or something happened, and he ended up not continuing out there.
Mm-hmm.
Hey, Michael.
Yes.
I had a couple questions. This is Mike Mantini.
Hey, Mike, how are you, buddy?
I'm doing good. Congrats on your project. Very, very, very well done. My question is how do you handle dust and particulate management? If you're getting bugs inside, I'm assuming that I don't see much grass out there.
Right.
I'm assuming the windstorms are pretty prevalent. And the other question I have is, do you have any futures? Do you have any plans in the futures to to be able to do flats and darks? Because I do understand there's a gizmo out there that would actually close off part of. You can remotely close it to do darks, for instance, and I assume you could do something clever for flats too.
Right. So I'll take those in order. The wind and dust. Yes. So there are dust devils out there all the time. I've actually registered at that observatory a 75-mile-per-hour dust devil hit the shed and didn't destroy anything. The big objective with something like this, where you have you know, a large surface that you're trying to seal and make weatherproof and bug-proof, the big objective is, from a dust perspective, you want to slow it down as it enters into the building. So when the wind speed drops and the dust coming in, it's not enough wind to continue carrying it onto the middle of the shed. So it ends up with the dust falling out very close to the walls. So that's one part of it. The other part is, if you can see, I park the scope so that the open end of the tube is facing away from the south wall. And that's because most of the wind in this area is prevalent from the south. So that way, any wind that blows in and dust that drops out away from the open end of the tube assembly. So with 6-month checkups on it, you know, there's certainly dust that you sweep up off the floor, but it's not like crazy caked in there and, you know, really, really bad. It actually is quite good. Oh, the second question.
Yes.
Yeah, so actually, if you see this big white panel back here, that's actually a flat panel. So I can change the park position to point the tube at the flat panel and do my flats. And while I was there this last time, I had intended to replace one of my filters in the filter wheel with a dark, so just a blank black plastic or something.
Mm-hmm.
And I ordered the one from, I think it's Astronomy or somebody makes a dark filter wheel. And in the description, it talks about being mounted in a 2-inch threaded fitting. And my filter wheel uses flat glass. So I thought, no big deal. When it gets here, I'll just disassemble it and put the, you know, put the innards into my filter wheel and I'll be good to go. When I got it, it turns out that that dark filter is actually stretched plastic. So if you take it out of that, it just folds up like cellophane. So that was on my to-do list. When I got there, it didn't work out so well, but it is on my future list and actually what I'm going to end up doing is just buying a sheet of black plastic and cutting a piece to fit that filter wheel exactly.
Just buy a flat glass UER and flat black it.
Okay, yeah.
Because it's the right size and everything.
Yep. So I'm going to go ahead and close this.
Yep. That's a beautiful view of the mountains, by the way.
Oh, yeah. That's the Panancios, I believe is the name of it.
Wow.
Yes,
So I
that's
think
awesome.
everyone should be able to come off of mute if you have any questions. I think we've got through all of the questions in the chat. So while people unmute, I'm going to ask just a couple of my own. So I think in your aerial shot, it looks now like you have a fence around it.
So yeah, that's actually the border of the park itself. So I'm at the extreme northwest corner of the RV park's property. And so that's the fence that they put up to keep animals out, like javelinas and cougars. There's actually been cougars in the park and different things, bobcats.
Chupacabras.
So yeah, and
Sorry.
and just people walking by. So that was one of the benefits. The reasons I chose this location specifically. One, it is right part of the RV park, but not in the RV park section, right? So part of their property, there are people that walk by frequently. You can see in this lower camera, this path around. So people walk around the park for exercise. One loop all the way around the park is 1 mile. So there's people constantly there around it. And if something is out of sorts, they would likely notice and let me know if I hadn't already noticed. There's also the park owners. They're not astronomy people specifically, but they're capable. You know, they have street smarts and some handyman skills. So if I needed something, I could talk them through doing something. And I have done that a couple of times. I've talked one of the park managers into going out there and pushing a power button because something locked up and I couldn't get into the system to reboot it myself. On that front, I do have 2 different internet connections. I have cellular LTE through AT&T, and then I have a backup link that's Wi-Fi linked into the campground's Wi-Fi. And that actually benefits both the campground and me because I help manage the campground Wi-Fi. So, and there I just got the chime that everything's closed up and good. So if the campground Wi-Fi has an issue and they're offline, I can come in through my cellular link into the shed and then bounce into their system and fix it internally, and vice versa. If my cellular link goes down, I can come in through the campground's Wi-Fi into my system and restart my cellular modem or whatever's necessary.
Awesome. The other question I had is kind of when you first started out this project, what were in essence your top two objectives of what you wanted to do, and then how well have those objectives been met? And the second part to that is, now that you're kind of on the the other side of this, do you think those objectives are still the most important ones, or do you think there's something kind of additional value or that if you would have said, yeah, I would have designed it more to do these things instead of the other two?
So my primary objective was to have a way to use my gear no matter where I was. We travel the country full time in a motor coach. I still have a lot of astronomy gear in my bays in the bottom of the coach that I could use when we're out mobile, doing outreach or solar observing or anything like that. But I wanted something where this investment in equipment I could use even if we were parked in downtown Las Vegas, right? Or if it was storming and nasty where I was, or whatever the case may be. So that was really my number one objective. And I definitely met that.
Mm-hmm.
But I don't get to do that as much as I thought I would. And that's really twofold or multifold as to why that is. The first one is I'm constantly picking up and doing new things and trying to figure new stuff out and do all kinds of stuff. I have my entire coach automated. I can talk to it through Google and Amazon and all that fun stuff. I'm constantly learning and figuring out new things to keep myself entertained. And because of that, I don't always think to use the observatory whenever I have the opportunity to. So that's one thing. And it's kind of one of those where if it's out of sight, out of mind, it's just not forefront. Mm-hmm. So one of the things I'm trying to start doing is actually setting calendar reminders to go off, you know, around new moon, especially like, hey, idiot, you got this great setup. It's dark out. You know, skies are good. You know, set something up and have it capture. The other thing was I envisioned in my head that I would have this deluge of data and I would get amazing at doing processing through PixInsight and everything else. And well, because of the failings of the first option where I'm not really using it as much, that second thing hasn't happened either. So I'm still very much a novice on PixInsight. But I hope that kind of meets.
Yep.
Okay.
Yep.
And as far as were they the most important ones, they were definitely valid. There's another RVer that I met at Rusty's. By the way, Rusty's is very big for RV astronomers. A lot of star parties and stuff happen there, and people travel from what was it?
Europe.
Amsterdam, I think.
There was Amsterdam, Switzerland,
Switzerland,
South Africa.
South Africa. There are people that actually schedule their vacations and fly in and rent a car in Tucson and drive the 2 hours and ship all their gear, or
they have cabins available for these as well.
And they have cabins to rent on site as well. So if you don't have an RV or you're flying in like that, there's options. So I met someone there who travels all the time, and he images basically every single clear night that he has, no matter where he is. And so he's always posting new pictures on Facebook. I'm like, crap, I really need to be doing this.
And that's Serenity Mobile Observatory.
Yes.
His website.
Serenity Mobile Observatory, if you want to check that out. Chris, really great guy, very good at PixInsight. And he does classes on PixInsight, teaches for like astronomers at these places. Anyway, that's, I think if I missed something, let me know.
No, good. Open it up to anybody else.
Got a couple
Feel free
quick
to
questions.
Yep.
You know, first a comment. I'll gladly use that telescope whenever you don't want to use it. First of all, but just let me know.
About renting it,
Now, this is more of a, you know, I don't expect you to give me the specifics, but if someone were to want to do something similar to what you did, can you, set some sort of just general budget expectations for both not including the telescope gear itself. I'm talking the infrastructure component and the recurring costs that someone should expect.
So I can tell you what I spent, and I can tell you what someone else has spent doing something similar but a little different. I have, in everything except for the astronomy gear itself, I have ballpark 15,000 in this setup. Now that is
unexpected, actually.
Yeah, that is me doing all my own work. That is me writing all my own code, which, by the way, I've open sourced. It's available on GitHub. So the Arduino controller code, the Python, I'm getting ready to be publishing the user interface stuff that's written and uses Node-RED and Node-RED dashboard. I'm working on getting all that put online. So that is all free for anybody who wants to do this. If you're handy with Arduinos and Raspberry Pis, you can put this together. At least that part of it. If you're not mechanically inclined, maybe you don't want to swing a hammer or something. I don't know, but so about 15,000 in all that. I can tell you that backyard observatories. It's a husband-wife pair, and I think they probably have a helper or two from time to time. They will fly out after all the materials have been delivered, and they will build from the ground up on your foundation a roll-off roof observatory with a motorized rolling mechanism and everything. I think that's a glitch in the video feed. I'm like, I didn't turn those lights back on. Anyway, and my understanding is like ground up, a functional hand controller operated observatory, ballpark of like 10 to 12,000 that they will build it for you. Now that's AC powered, so you need a power source of some sort. That's not setting piers. That's not, doing any of the rest of that. So, but that'll give you some idea.
How about the recurring costs?
Yes. So the recurring cost for for me, it's been a lot of touch-up paint. So, you know, whatever the exterior is, you got to maintain that. I have had to replace that linear actuator for the south flap once, had water ingress, and basically it just baked the circuit board inside that little actuator. I could still use the observatory. I could still roll the roof on and off. I just couldn't open that flap. So I had to be a little more selective in my targets. Not a huge issue, but inconvenience. That was $80 for that actuator, so not a huge issue. But you're going to have little things fail here and there, so you know, probably should account for that. The my internet access, that's a recurring cost. I got, being a mobile user and telecommute person all the time, I'm constantly watching for deals where you can get actually unlimited data plans for use for stuff like this. This particular one actually was, it was sold as a connected car plan using a device that plugged into the OBD2 port of your vehicle to give you Wi-Fi in your car for road trips and stuff. AT&T sold those for about 3 months, and it was $25 a month. No, $20 a month, completely unlimited. So I bought 4 of those. I've got 1 there, 1 in my Model X, 2 in my Coach. So yeah, $25 a month after taxes or something for the internet. That is completely atypical. Usually you're looking at least $70 or $80 a month.
Lease.
What's that?
Lease the property.
Oh, the property lease. Yeah. So Rusty's has the prices for that on their website. I think usually like right around 2,000 a month.
Or a year.
Or a year, sorry, 2,000 a year.
It's like,
Wow.
holy cow.
Yeah, that would be crazy. Yeah, no. So yeah, 2,000 a year for the lease on that.
If you are interested in
yeah.
in leasing at Rusty's, you should know that it is about 50 acres, but there are only 40 RV sites. I think there are 38 RV sites and 2 cabins. And the space that they have allotted for the Astro sheds or anything like that, they're also often separate. So everybody has their own area. Their RV sites are 200 feet long and I think 40 feet wide. And so there's plenty of space.
And then there's like 100 foot of space
yard
between the sites.
Yeah. So you're not right on top of everybody, and you get a lot of, I guess, twinkle from the little towns that are off, but there's definitely no street lamps or anything like that that are going to impede any kind of viewing.
If it's football night in Animus, you'll see a slight glow off to the east.
Yeah.
And that's about it.
That's about it.
You do see zodiacal light when it's, so you do get to see that there as well. It's really impressive.
I'm just going to put one of those little dog house igloos on your property and tie into the network and put mine in there.
So when you do visit your observatory, are you guys setting up in the campground or are you setting up outside your observatory?
We could do both.
We could do either, yeah. So part of the way the observatory lot is set up, there is a full pull through and around. So we could technically go out there and rough it. I mean, it's a 45-foot diesel pusher, so I don't know. Heated tile floors, you know, roughing it is objective at that point. But so we could rough it out there. But yeah, we generally operate plugged in and connected with full hookups. So, you know, if there was something going on that I needed to do some maintenance or something and the park was full, I could do that. But generally, we stay at the park.
Okay. But in other words, you could host a small star party out there.
Oh, yeah. There are a lot of star parties. Yeah.
Awesome.
My spot is only like 100 foot by 100 foot. So for the observatory, that's what that land sits on. So
yeah, and there's plenty of space for more sheds and more observatories. So
we could bring pup tents. You know, we would have a whole bunch of people bring pup tents.
And she does have a restroom and a shower.
There's a little kitchenette.
Little kitchen. So there was, so completely off topic, but when we got there, there was a guy that was literally sleeping in his Subaru and taking getting his pilot's license at the little local airport, you know, dirt runway type stuff. He was doing that because he wanted to fly the backcountry and bush country in Alaska. And the flight instructor right there in Rodeo had experience doing that. So he came there to do that. Well, he didn't have an RV and he didn't want to spend the money to rent one of the cabins because it, you know, for him, it was expensive. So he was sleeping in his Subaru with a little power cord out plugged into the RV pedestal with a heater and stuff because it was wintertime. And then he'd go take a shower and cook his food and stuff in the little community center.
But he did anticipate that the pilot wasn't going to be so relaxed in her training schedule. He thought it would be about 2 weeks and, you know, 2 and done and out of there. And it was, oh, well, we'll go up maybe tomorrow. It was extended quite a bit. So
he ended up being there for several months, and she got sick and he still never got his pilot's license. So he had to go back to California and finish up there. But anyway, just as an example.
So any other further questions from the group? I don't think there's anything left.
Thank you. It's been wonderful. I've enjoyed it, and I'm not even an astronomer. I just like hearing what everybody's doing.
Great.
Michael,
I'm glad it was at least entertaining.
Yeah.
It was nice.
Michael, do you come back this way at all to North Carolina?
We've only been back once.
Okay.
So yeah, not very frequently. That was about 4 years ago. But next time we're in the area, you know, pandemic allowing, I'll definitely ping the club and, you know, see if we want to get together and hang out some. Cause
currently we're outside of Dallas right now.
We're outside of Dallas right now, south of Fort Worth in Burleson.
I'm not in North Carolina anymore, so that doesn't do me any good.
Oh, well. I tried. So where are you, John?
I'm near Chattanooga. So.
Oh, okay.
Yeah.
That's between here and North Carolina.
Yeah.
We can make that work. We have wheels, so.
Yep, and you can give me the password and the access credentials on the way.
Right.
Well, he's not letting that one go.
Check out the Lehnanne Kidd.
He's not being too subtle with the hints.
No.
There was no attempt at subtlety whatsoever.
Yeah. So thank you very much, both of you. It was really good to see you guys. Glad that all is good. I saw a couple fur kitties walking around, so that's always good to see. Thank you very much for speaking to us. It was really, really enjoyable. Loved seeing the whole setup. It is very impressive. So great.
Thank
you. Know.
Well, if you're going to follow along, we actually have a travel blog. It's turtleherding.com, and he always has astronomy stuff up there, or any kind of tech and whiz stuff that he does.
Yeah, I will post that out to the listserv. So,
well, Michael, you have me excited because I do a lot with Arduinos. So now you kind of, because I said, wow, this is great. I'm going to get creative now. So.
Yeah. So if you go on GitHub, my username on there is Linux Kidd, LINUXKIDD. So if you search for me on there, you'll find all my repositories, which includes the CAN-based roll-roof controller.
Great. Thanks for doing that.
Yeah,
sure.
I got to tell you, my OCD would go crazy with the wiring you've got set up in there, though.
So I will say it started off much neater than that, but then as time went on and more things got added, it just kind of grew and grew.
Yeah.
And it's never been a priority to because it's working. So, you know, I don't want to really mess too much with it.
Yeah.
I got
Fantastic. All right, so we'll take about maybe just a 5-minute informal break, and then we just have a few topics to cover when we get back. Definitely, if anyone is interested in astronomy days, even what we're proposing to do with the pandemic, we'll give you an update on that. So thank you all. And
I
we'll
saw my Tesla tattoo mentioned in the.
Yeah, there you go. Yeah.